On to our next presentation, which will be presented by Dr. Prafulla Regmi, Assistant Professor at the Department of Poultry Science at the University of Georgia. The title of his project was Automated Tracking of Laying Hens in Cage-Free Aviary Environment using Affordable Radio Frequency Identification RFID chips.
Thank you for the introduction, Dr. Hurd, and good morning and welcome to all. I will try to take you towards laying hens now, and then also the theme of presentation will be more towards behavior and welfare, so we'll move a little bit away from health presentations. So this was a project that was funded by USPOULTRY and Egg a couple of years ago. And then this project initially started out as if we could test and validate some of these RFID sensors to track birds in aviary. But we ended up getting more data, and then we were trying to get some patterns and so on. So I'll try to walk you through some of those. So as we all know, the cage-free production in US is increasing year by year. And at the end of 2023, we are almost 39% of all of our laying hens in US are in cage-free production, which amounts to about almost 121 million laying hens. And this trend is continuing to increase, and about 17% of those layers are in commercial style aviary systems in the country. So what that means is, on the left here, you can see that the housing system was what it used to be, and still about a majority of our production is in these cages. So those would be the conventional cages where the birds had a limited space, and then there were less opportunities for birds to express different behaviors. But now we've moved to a system on the right where you can see there are a lot of birds in a single flock. They have the ability to move horizontally throughout the housing system, as well as go up and down between different tiers within those housing systems. So there is a chance for vertical ambulatory movements as well. So what that means for bird welfare is, initially move to the cage-free transition started out because of those behavioral restrictions. But if we look at welfare problems associated with these different housing systems, this was a really nice compilation study done by Dr. Don Lay and his group back in 2011, but all of those welfare problems are still quite relevant. So just to get you oriented, if there are more plus signs on those tables, that means the challenges are more severe or the response was more extreme. And you can see problems such as feather pecking and cannibalism, smothering and piling, and issues related to skeletal quality are seen more in cage-free production systems. And then other problems such as aggressive birds, foot-pad dermatitis, bumblefoot, and like increased stress response have been observed at various levels in different housing systems. Not just the welfare problems, we do have management problems as well. So eggs that are laid on the floor or outside the nest box. And then in some cases, even if we are thinking about 2 to 3% floor eggs, that becomes still a substantial amount when we keep in consideration the size of flock that we have in US production systems. And then another challenge is the nutritional challenges. So we have been traditionally feeding these cage-free birds based on the diets that were formulated for caged birds with addition of few extra energy. But the activity level or the physical activity that the birds perform in this system is significantly higher. They do activities such as jumping and moving up, short distance flying, and these are very energy expense activities. So we had a small pilot study where we were using accelerometers to look at birds in cages and birds in cage-free systems, and even within the morning or AM period and during the PM times, there is a significant variation in their activity level. So the challenge for nutritionists is how we incorporate that physical activity into diet formulation, and how we feed the birds that are more active a little bit more energy, and the other way around. So if you look at this video here, you can see that the birds are indulged in many different kind of behaviors there. You can see some birds jumping all the way from the top tier to the bottom. They're involved in different play behaviors and such. And then what that means is now with the newer systems, we have more space, bigger colonies, complex systems where they have nest boxes, scratch pad, floor or litter area where they can come and display different behavior. And all in all, in the past with case system, it used to be a person or two-person managing a flock of 100 to 500,000 birds. But now in the system, I think the situation has flipped around. And if you think about it carefully, it's like bird will tend to manage the farmers. So if you don't pay attention to what is going on with the birds, then you are in a little bit of trouble, because problems such as feather pecking, it will initially start out with few birds, but within a matter of 72 hours, it has a tendency to spread throughout your flock. So now the producers have to be very careful about keeping an eye on the bird. So we also think that how the hen interacts with the housing system in particular is tied to a lot of welfare and production challenges that we see in these systems. Are the birds using the resources that are appropriate for them? Are they not using that in a manner that they are competing towards the same resources? So what we then decided to do was, we decided to look at using RFID as a way of objectively tracking the movement in the birds. And then the first step was trying to see if we can validate the use of RFID in these groups. And then the second step was to see if we can get any information on spatial distribution of the birds in those systems. So for this project, we started out with commercial brown hens and brown egg strains, and then during the pullet phase, they were put in a litter and a slat system. As you can see in the picture, they had those slats to get them used to jumping early, and then once they were about 17 weeks, we moved them into a commercial style aviaries where there were 4 rooms of those aviaries, and each room had 4 sections within them, and within each section you could have 144 hens. So all in all, each room could house about 576 birds. And then, so the space requirement followed USPA guidelines where we gave them 1 square foot per bird on the total space. And then 40 birds from each one section within each room were chosen at random, and those were the birds we decided to deploy these RFID, passive RFID tags. So each tag came with a unique identifier, so we could follow the same bird throughout the time of the experiment. So we used traveling waveform antenna to get the recording. So as soon as the bird that was wearing a tag would come close to the antenna, we would get a hit. And then if you could look at the picture, okay. So if you could look at the picture on the right here, those yellow dots mark the area where we had the antenna. So that was at the entrance of each tier. So at the entrance of the bottom tier, entrance of the middle tier, and the entrance of the top tier. Just to remind you that the nest box in this system was only at the top tier. So the birds had to go to top to lay an egg in the nest box if she desires to do so. So we collected the data from about 29 to 42 weeks of age. In some rooms, we lost some of the data or some of the tags from the birds, but all in all, out of those 160 birds that we used, we were able to get data throughout a period of those 10 weeks from about 109 birds. And then, so this is just a rundown of the system that we used. So the RFID tag was adhered to the metal leg band, and then the leg band was deployed on the bird. And then the tracking was done through RF RAN reader. So 4 antennas could hook up to 1 reader, and then we will get real-time data as well as you could get a recorded data from those readers. And then those data were moved to the data server using a FileMaker Pro. So we have Kara here who did most of this coding so that we could get those data into an Excel format easily for further analysis. So you can see those metal leg bands, and then the bird wearing a tag, the reader there, and then when we looked at the data. So for the initial validation of these chips, we picked 12 birds per room, 12 of those birds that had RFID tag, and then we put some colorful leg bands on them so that we could use a videography or a video file on those to see if the location that we got from the RFID system matched with the actual location of the bird. And then We monitored them for a period of time, and then we looked at, we matched the data, the time-stamped data was matched between the RFID and the video file, and then we identified the exact bird where the RFID system would say would be and where the video system would say it would be. And then the correct location was identified with almost about 80% accuracy. But I think the actual accuracy is much higher. And then because when you're trying to film the birds from outside of the cages in those systems, you cannot capture all the depth of the cage. So I think this was more of a case of some of those birds being outside the view of the camera rather than the RFID not picking them. So now let's move to the interesting part. So in this diagram here, so this is a 24-hour activity period on a day-to-day basis for 2 hens. So your bird on the left is a hen 7. We assigned that arbitrarily. And then on the bird on your right is your hen 8. And on your y-axis, it has different tiers of those aviary systems, so top, middle, and bottom. And just by looking at it, you can pretty much tell me which bird was more active, right? So the bird 7 did move throughout the daytime, moving between top and bottom, whereas if you look at the bird 8, throughout those 10 consecutive days that we looked at, the bird pretty much just went to the top at the morning, probably to lay the egg in the nest box, but then it came down at the bottom, and then it was a flat line, like you would see in a ECG of a deceased person. Probably not a good analogy, but it was quite surprising that we were seeing that some birds were very active and some were not active at all. So this is the diagram throughout the period when we recorded the data from one of our most active bird and then the least active bird. So the most active bird on an average made have more than 20 transitions within each tier. So either going from bottom to middle, middle to top, or coming down from top to middle and middle to bottom. Whereas our least active bird made less than 2 transitions per day. So there was a significant differences. So we decided to look into it a little bit further. And then what we did was, based on the overall transition profile of each individual bird, we classified them into clusters of high activity, medium activity, and low activity. So low activity birds were the birds that were lower than the first quartile of those transition counts. The medium activity birds were the birds that were between the first and the third quartile of those transition counts. And then the high activity birds were the birds that were making more transition than the third quartile. And then, so if you think that in terms of how many transitions per day that those birds were making, low birds would be anywhere between less than 5 daily transitions between different tiers. Your medium activity birds were between 5 to 12 transitions between those tiers, and your high activity was more than 12 transitions per day. And then, all in all, it came out to be sort of like a classic Mendelian ratio of 1:1, where we saw our low activity birds were around 25% of the flock. So out of 106 birds that we initially looked at, it was around 26.42%. All these birds, if you look at the graph there, you can see the blue is representing your top tier, red is representing your middle tier, and your green is representing your bottom tier. And you can see all those transitions were less than 5. And then the medium activity bird, it was around 50% of the flock, and then they were making anywhere between 5 to 12 transitions throughout the period. And the one interesting thing that you can look at is on the x-axis is the age of the birds where we collected the data. So all in all, essentially, our low active bird never really changed and became very active all of a sudden, or a high active bird that I'm going to show you in this slide here, it never again became less active throughout the production period. So this was very consistent within individual bird. Their activity pattern was very consistent. However, there was significant variation between the birds. And then again, another 24.5% of birds that were categorized as high activity. So we decided to look into it a little bit further, and on this figure you can look at how activity level correlated with the time they spent on any particular tier. So there was no interaction between A's and the activity level on the time they spent on a bottom tier. So this is the data for the bottom tier of those aviary. However, what we found was there was a linear downward trend. That means as the activity level increases, that means as the bird, as we compare between low activity and high activity birds, they were starting to spend less and less time on the bottom tier. So the highly active birds, they will mostly be on the middle tier or the top tier. And then as the hens age, as they become older, they tend to spend more time in the bottom tier, but that response was not linear. It was a significant quadratic response on that. Similarly, once we moved to the middle tier, again, there was no interaction between activity level and the age of birds. But again, like we saw with the bottom tier, as the activity level increases, the time that they were spending on the middle tier also increases. So mostly the birds that were medium to high activity are the ones that were occupying those middle tiers. And then as the hens age, mean time spent on those middle tier again increases, but not in a linear manner. So the top tier activity was kind of interesting because the birds from all different activity levels started using top tier slightly less than when they started. But again, as the activity level increases, that means when you compare between low to medium and then medium to high or low to high, you will see that the birds that were highly or medium activity were just mostly spending time in the top tier, where the bottom low activity birds were mostly staying around the bottom tier. So we also divided and tried to look at the time they were spending at night, like where were they roosting at night? Is there a social structure to this activity pattern? Because one thing that we're kind of interested in, started thinking about is, are the birds that are trying to get into the top tier, they are the birds that are also roosting there at night. So are those the birds that are towards the dominant end on their social hierarchy in the system? And if they get the first dibs at the resources that are provided within those housing systems. And as you can see, the numbers are slightly in a smaller font, so I will have to do what Robbie says. You just have to believe me. But the birds with low activity were spending or roosting at night, with 80% of the birds were roosting at night on the bottom tier. Whereas if you look at your medium activity bird, now it was evenly split between the middle and the top tier when they were roosting at night. And then the top tier, the high activity birds were mostly roosting at the top tier and very less at the bottom tier. But so when we look at some of the video from these birds, especially at night, it was quite interesting that the birds in the bottom and the middle would be resting at night quite peacefully. There would be a pin drop silent, no movement, and then the birds just stayed there throughout the night. Whereas the birds on the top, they were jostling around throughout the night. Some of the birds were trying to push the other birds from the perches. You will even see some of the birds falling down. And then, so that is something that we're trying to look more to see if where they are nesting at night is a better clue of what their welfare status is going to be moving forward. So luckily, we also collected some bone samples from these birds that has the RFID tags, and then we decided to look at what their density or mineral content would be, or volume and the density would be looking like. So this is the tibia of the birds that were from different activities. And on the first graph, you have tibia volume, and then on the second graph, you have density. So, but between the activity levels, there was no difference in the density or volume of tibia. And which might be because tibia is a bone that is mostly loaded by their own body weight. So you might see a similar response when they're walking around versus if you are trying to move up and down. So generally, even when you compare between case and case-free, you might not see much changes in tibia. On the hind side, we should have also kept some humerus and then tried to look at it, because some of those wing movement when they were jumping up and down might have seen some differences there. But the interesting thing was, okay, some birds stayed in the bottom, some birds stayed in the top, some birds moved throughout all day, and then some birds didn't move at all. But what would that mean? And then, but when we look at their keel bones, we decided to score their keel bones on a very simplified scale of 0, 1, and 2. So a 0 keel is the one on the left where there was no fractures or no apparent deviations of the bone. And then a score 1 would be a bone with just a single fracture, and then a score 2 would be a bone with multiple fractures. And when we tried to correlate that with their activity pattern, then what we found was, so the first bar, the black bar, is high activity, and then the white bar is the low activity, whereas the gray is the medium activity. And as you can see, the low birds had significantly less severe keel fractures and significantly less incidence of keel fractures in the system. So when we try to score keel on a yes or no scale, it seems more closer, but if you get a keel bone and look at the fracture, it was without a doubt from the bird that was either from the high activity or the medium activity group. And I will probably leave you with more questions than answers at this stage because, okay, how does the activity profile change their egg laying behavior? Are these the birds that are the low activity birds are the ones that are contributing to floor eggs? What is going on with the egg quality? Do the birds that are moving more, are they depositing more into their egg cell? So those are the questions that we are trying to answer in the next study. So based on this project that we did, we have another study funded by Egg Industry Center. So that will give us an idea about what are the genetic profile, is there any genetic differences between these birds, between high and low activity. Again, just to remind you, these were birds from same genetic lines and that were kept in the same environmental situations. They had different diets between the rooms, but when we used diet as a random factor on analyzing the data, the diet didn't make any change on the activity level of these birds. So to summarize the results, there was a significant variation in space and resource utilization within a flock. And then within bird movement or within that individual bird, it was very consistent pattern from early in the lay cycle to late, or at least in the middle of the lay cycle. We looked at this until 42 weeks of age. And then resource utilization and welfare outcomes are correlated. So we looked at the keel fracture data, but in the next phase, we're trying to look at if there is a social structure, more defined social structures with this activity level, and if we can define welfare status just based on this tracking system. Because it makes sense, because keel fractures, when you think about in birds, it does not start to occur until they are laying their eggs. No matter which system you keep the birds, during the pullet phase, you would see at most maybe 2% keel fractures. But once they start producing eggs, they move to the hen house, and by the time they're about 25, 26 weeks old, you're already looking at 35 to 40% fractures. And that just keeps on increasing until they're about 50 weeks and plateaus at around 70 to 80% fractures in the flock. But if the movement profile does not change, could activity profile be used as a proxy of where the fracture status is going to look like, and so on? So we'll explore that in the next project. So with this, I would like to acknowledge Kiara, who happens to be here. She helped us run this project and did all the programming and coding. Ben Lawrence, who is a statistician at UGA, and then he helped me put this data together. Tori, who did the initial validation work, she is now at Penn State, and my collaborator, Darren, who I was hoping he would be here, but he's not here. And thank you, and with this, I would like to take any questions that you might have.
So it's interesting. You said that the activity is almost like a Mendelian segregation, the high and the low and the middle. Did you have a geneticist look into this? This actually be a good tool for select the more docile animals, right?
Yeah. Although I have to caution you a little bit, because one thing that I need to go back and figure out is, because we decided to look at, for low activity, anybody that was less than the first quartile, and then high activity more than the third quartile. So if by picking that, maybe we were leaning more towards the Mendelian segregation, but I do believe there were more birds from medium activity than the lower high. So yes, and then in the second experiment that we're going to start soon, So we're hoping to start that project at the aviary facility at NC State, but the housing system has not been built completely yet. So the timeline is probably May of this year. But on that one, we're going to cluster these birds into different activity levels, and then we'll look at their genetic makeup and then see if they also differ in the genetic makeup and how that helps with the activity level. And yeah.
It would be interesting waiting to see egg production results, right?
Yes. Yeah. The challenge is in an aviary system, it is very difficult to track the egg back to the bird. So unless we have like a trap nest system or some way to track the bird, even if you try to put RFID in the nest box, then you'll have to associate it with like a weight factor to decide which bird laid which egg. And then it was an interesting scenario where we went back and looked at some backyard poultry forums, and then they used this food dye on the vent of the bird, and then the bird would lay colored egg for 2 to 3 days. So we might have to do that to track the egg back to the chicken in the system.
I think we're going to have to move on to our next one, but you can catch Dr. Regmi right outside.
Thank you.
Thank you.